Hi everybody, it's Mr. DeGrain, and today we're going to talk about solving exponential and logarithmic equations by undoing. This undoing something is stuff we've looked at before. It's just the idea of undoing each operation as it comes up. So we're going to look at these three equations first. Log base 4 of x equals -3, 5 to the x equals 80, and 3x minus 10 equals 35. And my claim is that if you can solve these three equations, you can solve lots of equations. So pause the video and give these a shot, and I'll wait for you here. Go ahead, pause it and try them. Okay, so as you solved it, I would bet you rewrote this logarithmic equation as an exponential and wrote 4 to the -3 equals x, and you'd be absolutely right. Remember, 4 to the -3 is the reciprocal, because it's a negative exponent, it's the reciprocal of 4 to the third. Well, 4 to the third is, let's see, 4 times 4 is 16 times 4 is 64. This is 1/64 equals x. 5 to the x equals 80, I bet you rewrote that as a logarithm and did x equals log base 5 of 80, which doesn't work out all that nicely. I do know that 5 squared gives me 25, and 5 cubed gives me 125, so I expect the answer to be somewhere between 2 and 3. If you need to type it into your calculator, you can type it in like this. Remember, log of 80 divided by the log of 5. Make sure you get your parentheses in the right spot, and you get x is about 2.72. This last one, oh, you've been solving these forever. We just kind of undo each side, and you got something like this. When you divide it by 3, you got x equals 15. And like I said, if you can solve all of these problems, then you can solve pretty much any problem I'm about to throw at you. The one exception would be a problem like this. If it said log base 4 of x equals -3 plus x. This one we're not going to be able to solve this way, because if we undo the logarithm, we're going to end up with this x over here in the exponent. This -3 that's here would be -3 plus x. So by undoing the log to get this x by itself, we'd end up putting it in exponential form, which would put this x in the exponent, which we can undo using logarithm, and we're right back where we started. The only choice we have with a problem where there's something inside a logarithm and not is to graph it. And if I graph this quickly, remember log base 4 of x, the point 1 comma 0 is on the graph, because log base 4 of 1 is 0, and 4 comma 1 is on the graph. Log base 4 of 4 is 1, and the graph looks something like this. And then -3 plus x would start down at -3 and go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and we get something like this. And we can see there's one solution right here at x equals 4 if we make the graph really accurate. There's another solution way over here, which we would have to figure out using a graphing calculator, because that's not even going to show up nicely on a grid. So we're not even going to worry about a problem like that right now, just the undoing problems. Okay, so here's a couple more. Try these out, these two equations at the bottom, and see what you come up with. Pause the video and try them, and then I'll wait for you here, and I'll show you the solutions in a minute. Okay, so let's take a look at these problems. The thing I notice is that this x is here inside of a logarithm, so at some point I have to undo the logarithm. But there's stuff outside the logarithm. I've got this 5 times and this -8, so what I need to do is get those out of the way. So just like normally, I'm going to start by adding 8 to both sides. And I get 5 times log base 2 of x is equal to 35, and I divide by 5, and I get log base 2 of x equals 7, and so I know that 2 to the 7th equals x. And if I count it out, let's see, that's 2, 4, 8, 16, 32, 64, 128 equals x. I just multiplied by 2 7 times. This one here, same thing. I've got this 5 to the x in the middle of the problem. So to solve for x, I have to get rid of everything else that's not in there. So I'm going to subtract the 3. I always start by undoing the subtraction, because that's kind of the last thing you do in the order of operations. So it's the first thing you undo when you solve. I'm going to get 40 equals 4 times 5 to the x. If I divide by 4, I'll get 10 equals 5 to the x. And again, I have to write this as a logarithm. So 5 to the x, I got log base 5 of 10 equals x. And again, I need to do that on my calculator if I want to get a decimal approximation. Log base 5 of 10 is actually the exact answer, but if I want to get a decimal approximation, I have to kind of do that little change of base business on my calculator. Log of 10 divided by log of 5 equals x, and so I get about 1.43 is x. That's approximately equal to. So let's try another set. I'll leave those two up for a moment, and I want you to try these two at the bottom and see what you come up with. Again, you guys pause the video, and I'll wait for you here. Okay, so let's do these together. These look a little bit more complicated because there's stuff inside the logarithm and inside the exponent, but ultimately it's just going to change how the problem finishes off. For this first problem, I'm still going to start by subtracting 2, and I get 4 log of x minus 7 equals 18. So I divide by 4, and I get log of x minus 7 equals 18 fourths, which simplifies. If I take a 2 out, I'm going to get 9 halves, or 4.5. And now how do I undo the logarithm? You're going to say, hey, DeCrane, there's no base on that logarithm. But remember, the base, if there is no base written in, we understand that it's 10. So I've got x minus 7 equals 10 to the 4.5. That's 9 halves. And then I add 7 to both sides. X equals 10 to the 4.5 plus 7. And I can leave it like that. That's perfectly fine. That's an exact answer. Again, if I want a decimal approximation, I type it into the calculator, and I'm going to get x is approximately 31,629 and 78 hundredths. And that's that answer. On the other side, I can start the same way. I'm going to subtract 7 from both sides, and I've got negative 3 e to the x plus 5 equals negative 9. I'm going to divide both sides by negative 3, and I get e to the x plus 5 equals 3. So I undo the logarithm. You're saying, wait, isn't e a variable? And remember, e is not a variable. E is the base of the natural logarithm. So x plus 5 equals natural log of 3. And to undo this, I subtract 5 from both sides. And sometimes we're tempted to say this is going to be natural log of negative 2. You do 3 take away 5 and get negative 2. But that would be a horrible mistake. Remember, natural log of 3, that's a number all by itself that I'm going to take 5 away from. So I can't combine this. And in fact, these are not what we would call like terms, because this is the natural log of a number. That's just minus 5. So I have to leave it as natural log of 3 minus 5. If you want to put it on your calculator, you can type in natural log of 3 minus 5, and we'll get negative 3.901 approximately. All right, so that's how you solve these things by undoing. I'm going to leave you with this one to try, and if you want to know what this one is, you're just going to have to try it on your own. I guarantee you, though, that you can solve it just like the ones we've been doing. You'll have to undo a square root and absolute value as you go, but I'm pretty sure you can do that. Talk to you later. Bye.